Hello, and welcome to Mrs. Bada's screencast of tonight's homework. Monday, December 11th, your homework was page 27 in our Unit 3 packet. And we're going to start with exercise 2, which is review of graphing piecewise functions. And remember, piecewise functions just have us graphing a different rule for different inputs or x's. So if we take a look at the equation f of x given in exercise 2, for all the values of x that are less than or equal to 1, we're going to use the function equation x plus 3. And then all the values greater than or equal to 1, we're going to use 6 minus 2x. Now, the 1 is where our graph is going to change, and if both inequalities contain that equal sign, then that means that 1 is the same for both equations. So we end up with the same output for x equals 1 no matter which rule we use. All right, so they're asking us to graph it over the specific interval, and this is important, of -4 to 4. Negative 4 is less than or equal to x is less than or equal to 4. They're giving us a specific domain interval. That means we do not put arrows at the end of our graph because we are only looking at these x values from -4 to 4. So, for the x values of -4, -3, -2, -1, 0, and 1, we're going to use that first function, x plus 3. So I'm just going to quickly do my math here in my head and write down the point that I get when x is -4. -4 plus 3 is -1, so that's the point -4, -1. When x is -3, we get 0, so that's -3, 0. When x is -2, you get 1, so that's -2, 1. When x is -1, we get 2, so -1, 2. 0 gives us, 0 for an x gives us 3 for a y, so that's 0, 3. And 1 gives us 4, 1, 4. Okay, now if I were to substitute 1 into that second function rule, 6 minus 2x, 6 minus 2 times 1 is 6 minus 2, which also gives you 4. So for 2, 3, and 4, we have to use that bottom function. And so 6 minus 2 times 2 is 2, so that's the point 2, 2. 6 minus 2 times 3 is 0, so that's the point 3, 0. And 6 minus 2 times 4 is -2, so that point is 4, -2. All right, so now I'm going to graph my points here, and I'm going to graph them in the colors that correspond to the function rule that we're using. So -4, -1 is here, -3, 0, -2, 1, -1, 2, 0, 3, and 1, 4. And here's where we change over to the other rule, 2, 2, 3, 0, 4, -2. Draw your lines, and remember we don't put arrows because we are graphing it over the interval of -4 to 4, so we only want those x values. Okay, what I like about this question, this page, is it has us review graphing a piecewise function and then also talking about all the graphical features we learned about today, or we talked about today. So the zeros of our function is what they're asking for in B, and your zeros is where it crosses the x-axis. Okay, they're also known as x-intercepts. So you're going to look at the x-axis, and we can see that our graph intersects the x-axis in two places, here and here, when x is -3 and when x is +3. The y-intercept is where our graph crosses the y-axis. And remember, like we talked about in class today, there's always going to be only one y-intercept if we're talking about a function. And that's at the point 0, 3, or you could say y equals 3. All right, now this is what we talked about that was new today, giving intervals over which the function is increasing and decreasing. And I said, remember, pretend you're on a roller coaster. Where are you if you're going up the roller coaster, if you're going up? And the area that we are going up is from here to here. Now, that whole time you're going up. What are the x values when you're going up? Well, your x value here is -4, and you stop increasing or going up here when x is 1. So we're going to write an inequality to represent that area of our graph with the x values. -1 is less than x is less than +1. We talked about this today. With domain and range, we use less than or equal to signs. But when we're talking about increasing and decreasing, we don't. Because at these points, at the point negative, where x is -4, and at the point where x is 1, we're not increasing or decreasing. You're just standing still. Okay, and then decreasing is when you're going down. So you're going down the hill, and right here we go down until this point right here. So our x value here is 1. That's where we start decreasing. And we stop decreasing when our graph ends at x equals 4. So we are decreasing over the interval 1 is less than x is less than 4. E says give the coordinates of the one turning point and classify it as either a relative max or a relative min. Okay, well, the turning point we can see is right here. And it's the highest point in our graph, and so it is a maximum. So the coordinates here are 1, 4, and it is a maximum. F is review of something we did last week and the week before. Use your graph to find all solutions to f of x equals 2. So we're looking for where f of x equals 2. Well, f of x is the same thing as y, so we're really just looking for where y is 2. All right, well, y is 2 all along this line, y equals 2. And so where does that intersect our graph? Remember, we don't want where it intersects the axes, just the graph. It intersects here, and it intersects there. So the function equals 2 when x is -1, because this is the point -1, 2, and when x is +1, because this is the point +2. For both of these, the y value, or the function, equals 2. So x equals -1 and 2. It says to illustrate your solution graphically, which I just did there, and find evidence in the table we created. Well, let's see. We're looking for where our function or our y value is +2. And it's right here at -1, 2, like we said, when x is -1, and right here at 2, 2, when x is 2. Okay, I put a star next to G because we didn't specifically talk about this in class, but I wanted to see if you were able to kind of figure it out on your own. State the interval over which this function is positive. Well, what do we know about positive? Positive numbers are greater than 0. So we want to know where this function is greater than 0. I need a new color here. Something I haven't used yet. Let's go with this red. So the x-axis is where our y value is 0. So anything above that is positive. So our graph is positive in this little highlighted area from here to here, because it's where all of our y values are greater than 0. And that is from -3 to +3. So I can represent that with the inequality, -3 is less than x is less than 3. And that means for the x values between -3 and 3, our y values are positive. Now, let's take a look at that on our graph. Here is where our x values are between -3 and 3. -2, 1, -1, 2, 0, 1, and 2. At -3, our y value is 0. That's not positive. 0 is neither positive or negative. But at -2, our y value is positive. At -1, our y value is positive. At 0, our y value is positive. At 1, our y value is positive. And at 2, our y value is positive. All up until 3 when we hit 0, which is neither positive or negative. All right, so there is your homework. We are going to continue working with graphs over the next few days. So if you're struggling with any of this, make sure you come see me, or you ask a question, or you rewatch this video. But there's lots of things you can do to help yourself to be successful in this unit. Have a great night.